Have you ever stopped to wonder about the world around you? Not the big, grand things, distant galaxies, or the mysteries of the deep ocean, but the small, everyday things you see and use without a second thought. What if I told you your simple morning routine is packed with more amazing science than a blockbuster movie? From the moment you wake up to the moment you go to sleep, you are surrounded by incredible scientific principles at work. It's a world of hidden wonders, a secret laboratory that you live in every single day. The truth is, science isn't just something that happens in a lab with bubbling beakers. It's right there in your kitchen, in the sky above your head, and even in the humble office supplies on your desk. Let's think about it. The alarm that wakes you up uses electricity, a flow of tiny particles called electrons. The hot shower you take involves the states of matter, as liquid water turns into steam. Even the act of seeing these things involves light bouncing off objects and entering your eyes, where your brain, a magnificent biological computer, processes the information. Every single object, every single action, has a story to tell, and that story is written in the language of science. Once you start looking, you'll find that the most ordinary things can become extraordinary. So let's take a closer look at a few things you probably encounter all the time. By the end of this, you'll never look at a banana, the sky, or even a sticky note the same way again. Science rules. Let's start in the kitchen, with a box that performs what seems like magic, the microwave oven. You put cold leftovers in, press a few buttons, and a minute later, you have a steaming hot meal. How does it do that? The secret is in its name: microwaves. These are invisible waves similar to radio waves, but with a very specific talent. They are exceptionally good at making one particular molecule dance, the water molecule. Your food, whether it's soup, pizza, or last night's lasagna, is filled with water. When you turn the microwave on, an electron tube called a magnetron generates these microwaves and floods the inside of the oven with them. The water molecules frantically try to flip back and forth to align with this changing field. They start wiggling, spinning, around billions of times per second. Now, what happens when you rub your hands together really fast? They get warm, right? That's because of friction. The same thing is happening inside your food on a microscopic level. As all those trillions of water molecules wiggle, jiggle, and bump into each other, they generate friction, and that friction creates heat. It's this molecular dance party that heats your food from the inside out. This is also why things with very little water, like a dry plate, don't get hot in the microwave, while the wet food on top of it gets piping hot. So the next time you're impatiently waiting for your popcorn to pop, remember what's happening in there. It's not just a boring box. It's a high-tech chamber designed to excite water molecules into a frenzy. Each kernel of popcorn has a tiny droplet of water trapped inside a hard shell. The microwaves make that water molecule dance, creating heat and pressure, until, pop, the shell bursts. You have a fluffy, delicious snack. It's a beautiful and edible demonstration of physics in action. Consider the microwave. We look at it every day. But have you ever truly asked yourself why the sky is blue? A common guess is that it reflects the blue of the oceans, but that's not it at all. Sunlight, which we see as white light, is actually made up of all the colors of the rainbow mixed together: red, orange, yellow, green, blue, violet. Blue and violet light travel in shorter, choppier waves, while red and orange light travel in longer, lazier waves. Now think of our planet's atmosphere. It's not empty space, it's a thick blanket of gas, mostly nitrogen, oxygen, dust, and water vapor. When sunlight enters our atmosphere, it's like a superhighway of light waves encountering a whole bunch of tiny obstacles. The long, lazy red and orange waves are pretty good at just cruising past these gas molecules without much trouble. They mostly travel in a straight line from the sun to your eyes, which is why the sun itself looks yellowish-white. But the short, choppy blue waves are a different story. Because of their shorter wavelength, blue and violet light are much more likely to bump into and get scattered by the gas molecules in the air. This phenomenon is called Rayleigh scattering. Imagine throwing different-sized balls at a forest of thin poles. The big beach balls, like red light, might just push through. But the small tennis balls, like blue light, would hit the poles and bounce off in every direction. That's what happens to blue light in our atmosphere. It hits the gas molecules and scatters all over the sky, from every direction, until the whole sky appears to be filled with blue light. So when you look up at the sky on a clear day, you're seeing countless rays of blue light that have been scattered and bounced around by the air itself. This is also why sunsets are red. When the sun is low on the horizon, most of the blue light has already been scattered away, leaving behind the longer wavelengths of red and orange to paint the sky. Science is beautiful. Let's move on to something you might have in your lunchbox, a banana. It seems simple enough. It starts green, turns yellow, and if you wait too long, it gets brown and mushy. But what's actually happening during that process? It's a fascinating and carefully controlled chemical journey. A green banana is hard and not very sweet because it's full of starch, the plant's way of storing energy for later. As the banana begins to ripen, it releases a special plant hormone, a gas called ethylene. This gas is the superstar of the banana world. Ethylene acts as a chemical signal that kicks off the ripening process. It triggers the production of enzymes inside the banana. One enzyme, amylase, breaks down complex starches into simple sugars like fructose and glucose. That's why a ripe banana is sweeter and softer than a green one. The firm, starchy structure is being converted into soft, sweet mush. Another enzyme, pectinase, breaks down the pectin that holds cell walls together, which makes the banana soften even more. Did you know this process can be contagious? Because ethylene is a gas, a ripening banana releases it into the air and signals nearby fruit to ripen too. That's why a whole bunch of bananas ripens together. You can speed up other fruits like an avocado or a tomato by placing them in a paper bag with a ripe banana. The trapped ethylene accelerates ripening. But what about those brown spots? As ripening continues, phenolic compounds in the peel react with enzymes to create melanin, the same pigment in our skin and hair. So a spotted banana isn't necessarily bad. It's just further along in the chemical transformation from a starchy energy store to a sweet, sugary treat. Finally, let's consider an office icon, the Post-it note. It's brilliant in its simplicity. It's sticky enough to hold, but not so sticky that it tears the paper or leaves a residue. How is that possible? The answer lies in a story of a scientific mistake. In 1968, Dr. Spencer Silver at 3M tried to make a super strong adhesive. Instead, he accidentally made the opposite, a very, very weak one. The adhesive was made of tiny, indestructible acrylic microspheres. It stuck, unstuck, restuck, over and over again. At first, nobody knew what to do with this low-tack adhesive. It was a solution without a problem. Then another 3M scientist, Art Fry, had a eureka moment. Fry was a singer in his church choir. He was frustrated that paper bookmarks kept falling out of hymnals. He remembered Silver's weak adhesive and had an idea. What if he could put that adhesive on bookmarks? The magic is in those microspheres. Unlike regular adhesives like duct tape, which flow and create a strong, permanent bond, Post-it adhesive only touches at a few points, the tops of tiny spheres. That makes just enough stick to hold the note. When you peel it off, the spheres roll or lift off the surface without tearing the paper or leaving a sticky mess. The spheres are durable and can repeat this many times until dust and fibers clog them. That little yellow square on your monitor is a marvel of material science. A lab failure plus creativity became a world-changing invention. It's a sticky situation, but in the best way possible. Science is everywhere. From the waves in your microwave to the scattered light in the sky, and from the chemical reactions in your fruit bowl to the accidental genius on your desk. Science is truly all around us. We've only just scratched the surface of the amazing phenomena hidden in plain sight. Every object has a story, every process has a principle, and every single day offers a new opportunity to ask why. And discover something incredible about the world we inhabit. If you enjoyed this peek into the hidden science of everyday life and want to keep your curiosity engine running, then we invite you to join our community. Be sure to subscribe to our channel and like this video to let us know you want more adventures into the world of science. Let's learn together, because the more we understand our world, the better we can appreciate it and our place within it. Thank you for watching.